What's up, everybody? Today, here we go. Okay, so we are, or we should be streaming. Let me just check real quick. Let me go to my channel real quickly, and let me just confirm that I am indeed streaming. It should be popping up. Yes. Okay, so this is happening, right? I'm not exactly sure. I was hoping that it would show me actually doing it, but is this here? Is it here? Come on. This is the one, right? Ah, snap, it's not the one. What the heck? Oh gosh. What's this about? Yes, that's the one. Now, I just want it going through to this one. I don't understand. Oh gosh. I don't understand these, to be quite honest. What's up, good PvP? How you doing? This is having trouble. Live control room? Is that what it is? We are not receiving. Start your hangout on air to monitor it from here. Wait, what? Do I have to create a monitor? What are we talking about? Your hangout? Google Hangouts? I'm pretty sure. Anyways, whatever. We're streaming. It's just not exactly to the one that I had wanted it to be to. So, let's get this started here. I will 3, 2, 1, begin. Okay. We do exclamation point, doc type, HTML, and then we gotta do head. Oh, my bad. Head. And we gotta do the script. And let's go over here. Type equals text slash JavaScript. And then src equals oh my bad, I need to change something. p5 min.js, and then hang on. Right here that needs to be moved. And let's change this to sketch.js. There we go. That should be good. Now within here, we are going to call the function setup. There we go. Function draw. Now, we should be good. Let me just do a test. Create canvas. Let's do 500 by 500. We'll figure out the dimensions later and set the background to 51. Oh, didn't mean that. There we go. Nice. Looks like it's working. Now we are going to be creating a game called Breakout. I actually have a picture of it, I think. Breakout. It's kind of like this. The one where you have to break the words. Or not the words, the little blocks. In order to, you know, I guess break out. I wish, okay, here. If we can play an online Breakout, because I've only played this, like, once. If this is, ooh, there's an Atari arcade. Oh, not what I wanted. Well, I kind of wanted that one. Let's just see what this is. I'm not exactly sure. Oh, wow. Wow, they have a lot of stuff. Can I, wow, what is this? Super Breakout. Internet. Single player. Play. Okay, whatever. You get the point. Let's start this off. So if we do, we obviously need the paddle, so var paddle, we need a paddle X. We also need, here, I'm just going to put this in the same line, paddle velocity. So this is going to be the paddle's X coordinate, this is going to be the paddle's velocity. The Y coordinate will stay the same, so I don't even need that. Let's make this wider than it is tall. So let's do 600, and we'll do 400. I think that should be good. Yeah, that should be good. aspect ratio. Let's draw a paddle. First thing we'll do, I'm not exactly sure where I'll go from there, but we will do rectangle. We will say at paddle, and then the y value, or the horizon as we had last time, we'll make it 40. We'll make the paddle itself, we'll make it, what should the width be? 100 by 10? Let's try that. Oh, we have an error. Oh yes, I know. That was a pretty dumb mistake. It's going to be width divided by 2 minus the actual width of, or half of the width of the paddle. Just to get it centered. And then paddle velocity is going to equal 0. There we go. My bad. We need to do height minus 40, and now it's at the bottom. So that's our paddle. We want to handle keys. Okay, let's do handle. Let's just call it movement, because, hang on. There we go. We will handle the movement in this function. Handle movement. And here is where we are going to say paddle plus equals paddle velocity. Paddle velocity. And we are actually going to say, every time it moves, I'm just going to say paddle velocity times equals 0.3, 0.7. Let's try 0.7. I'm not exactly sure what it should be, and man, my gums are hurting. I got my wisdom teeth taken out, and it is really, really hurting. Okay, so now we will do if, and then this will be key is down, left arrow. There we go, and let's copy this. I don't know why it does that. Oh, yeah, there we go. Okay, so this one will be right arrow. There, okay. So left arrow, this actually needs to be an else if. This should be here. So if the left arrow key is down, I actually want to go to P5, and I want to say tilt. Can I, here, oh, here we go. Device, yeah, I'm actually not going to, well, should I? I don't know if I should. Device turned, can I do that? Okay, it says run this example on a mobile device and rotate it. Yeah, I will have to look into this another time to, really understand what it does. So if we do left arrow, then we want to move to left. So we're going to say paddle velocity minus equals, let's say something like 0, or let's say 1 for now. Or 4. We can always change it. With the right hand side, we are going to add 4. And we are also going to say constrain, or paddle equals constrain paddle, and we're going to constrain it from 0 to the width minus the width of the paddle, which is 100. So that is going to keep this edge from going past this right hand side, and it's going to keep this edge from going past this left hand side. This should be working. Neato. Looking good. I'm enjoying it. Let's try. Now we need a ball. Okay. Var ball, and then ball velocity. There we go. And we will say ball equals create vector. Oh. And then ball v also equals create vector. I think the ball velocity is going to be, I think it's just going to be random, but obviously it needs to go downward. So the ball is going to be drawn at width divided by 2, height divided by 2, and I always forget to put spaces in between. And then the ball velocity is going to be initialized with a vector aimed downward. It's gonna be, okay, it's gonna be aimed downward and going at a random x. So from -5 or -3 to +3. Let's try that. That should give it some randomness on the x scale. And then random from 2 to 4. Yes, okay, that's correct, because this will actually be moving downward on the screen because we are on the fourth quadrant of a plane. Now, what we want to do is draw stuff. And we'll name this one paddle, and then we'll do a ellipse at the ball.x, ball.y, with a radius of, what should it be? I think the radius should be something like 20. Let's try that. And then the ball, and there we go. One thing I forgot to do is, okay, so that's a paddle. Let's name this, you know what, we're gonna just say handle paddle, and name this one handle paddle, and then we'll have a handle ball, and then that's what we will create next. Function handle ball. There we go. Let's do, obviously that's the paddle. I don't even need to comment that. Now what we do is we say ball dot, can I just say, I forgot, P5 reference, I need this again, vector, there, let's exit, can I say add, there, okay, so it just adds everything, ball dot add ball velocity. That should be it for the ball. Currently, it's just going to go through, yes, obviously. Okay, so there we go. We've got a random x, and yes, okay. So now what we need to do is say, instead of adding the velocity right there, we just need to, hang on, let me charge my phone real quick. I need to plug this in. It's at 8% and it's gonna die, so un momento. There we go. Okay, so now that's plugged in. We're making good progress. This is 12 minutes in and we've got a ball and a paddle. So now what we want to do is check for the collisions. So if the ball's y value is greater than this line right here. I actually have paint 3D is much better. I'm enjoying that. Let's not worry about that. So right now our canvas looks like this. If we can, I wish we could just import a screenshot. Can we do that? No, whatever. So this is kind of what it looks like. Here is a plane. I need to learn how to draw a straight line. There we go. This is the plane. Here is our paddle right here. Here, let me get a better color. This is our paddle. And let me fill this in. There we go. That's our paddle. If the ball decides to, okay, that's that. If the ball decides to go greater than the, oh, didn't mean to do that. My bad. I'm gonna get better at this someday. So if the ball goes past the y value, meaning the y value is greater than this point, then we need to check if it falls between the bounds of the paddle. And if they do, then we're gonna ricochet it. If not, we'll let it through, and then we'll check if the y is greater than the height of the screen to know if they lost. So that seems like a good thing to here. Okay, let's do this. You know what? I think what we're gonna have to do is create a function check collision, because essentially we are just going to have paddles, you know, air quotes, paddles up here, you know, in different colors and everything. And so we're just going to say we're just going to create a check collision, and we are just going to say function here check is or is colliding with, and we'll just do this, and then we will have object obj1 or e1 e2. That will be the two things. So we'll just say for, and we're going to have an array of paddles, but we will say, you know what I think we need to do is create a, I think what we should do, I don't know if it should be here. Okay, what I really need to do is learn how to make an object in not in P5, JS object there. Okay, let's try this. So we have a new object and we say all this stuff. Okay, yes, object notation. Well, this is object notation. What is array notation? I don't really know what that notation is called. But here, where do we define the actual properties? You see, it's kind of like this, but I don't know if I can use if I can say, okay, let's try this. Using a constructor. Let's try that. I'm gonna go for that real quick and just keep it in this function, and we will name this block. So we will say xy, yeah, xy, and then maybe a color just in case. So this dot x equals x, this dot y equals y, and then we will say then we shall say, obviously it's got to be a width and height. Yeah, let's do a width and a height. Width, height, and color. So this dot w equals w, this dot h equals h, and also we will need a, I think that should be all. I think that should be all for now. So if we create, yes, okay, so we can create a var blocks. So blocks is going to be the array which handles whether or not I guess you know, all of the blocks at the top are broken or not. Let's do this. Populate blocks. Let's go for it. Then we will say down here, let's put it under the handling function and the constructor function populate blocks. Then we will say return, we will say var b, and that's going to be the array, and then we will say return b, and that's what it is going to be equal to. Now, if we have 4, how many blocks should be on here? I'm thinking 10. Var I equals 0, I is less than 10, I plus plus. Now, what we want to do is say, we'll create some sort of spacing for it. We'll create a width and a height. We also want var, here, say row, there, var call equals 0. Call is less than 4. I think that's good. We can always change it. And then we can say, let's try this. B dot push, and we'll say new block, and what we need is row times width. Let's try this. Var width equals, and let's say 30 pixels. Var height equals, I'm gonna say this is, and let's say this is 20 pixels, and let's say this is 40 pixels. Why does my mouse keep turning off? Wow, I'm having problems with my mouse right now. Maybe a connection is this or something. So row times the width, and then I think we should do plus padding. No, okay. There, row times width plus width, and then we will say, I'm actually gonna create a whole a whole line for this. Call times height plus height, and then we will say, now we need a width and a height, so width height, and then a color, so we'll just pass null. So there, that's good. Here, we'll add a variable padding, which is going to be the space in between. We'll say that's 10 for now. Padding, and then we will say the same thing here. So when we do that, now we have to draw those. So for var I equals, well, in, let's just say var I in blocks, and then we will say, you see, now I want to create a draw function, but it's too simple. We will actually, we're gonna have to loop this backward. So we are going to say I is less than blocks dot length I plus plus. Now what we want to do is, I'm just gonna say blocks, there we go. Also what we want to do, this dot is dead, is alive, here. Is intact. There we go. I'm just gonna name it this dot intact equals true, and then we will say, we'll come over here, if I, or blocks of I dot intact, so if it's intact, then we draw it. So now we say rect, actually, my bad, if it's intact, then we say fill C, that should be good. I actually need to make these, I'll make this one 255, and we'll make the ball, FF, you know what, let's make it 99 EE 99. What does that look like? We have an error. My bad. I forgot to surround these in quotes. There we go. Okay, so it's a nice green Should be good. Now, let's actually make this FF, just to see what it'll give us. Nice blue, whatever. Maybe I'll change the color every once in a while. You know what? Let's just make it gray. Yeah, that should be fine. And I honestly don't want to stroke on any of these. No stroke. Oh, my bad. Didn't capitalize the S in stroke. There we go. That's a bit better. I kind of like that more. So if we say handlebar, and then we have the is colliding, and then we have the block, I'm actually going to comment some of this, or my bad. Ah, goodness. There, okay. Block object. And then, that should be good. So, we populate the blocks. We give them all their little, what's it called? And we gotta draw them. My bad. I completely forgot to draw them. Rectangle act, we are going to say blocks of I dot X, blocks of I dot Y, blocks of I dot width, blocks of I dot height. I'm creating this. I'm creating the width and the height just because if for some reason we want them to be able to change, are we having trouble? Yes, we are. I'm going to shift this back a little bit. There we go. C is not defined. Right, it is not defined. We will just say all of these are white. Didn't mean that. So F, there. C is still not defined. What did I mess up on? X, Y, width, height, color. Oh. This dot C equals C. There we go. Oh, well. Okay, that's odd. Okay, so we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now are we having trouble? Line 33 is where we're having trouble. Fill, and we say C. Oh, goodness. That's why. So we will do blocks of I, dot C. There. Okay, now let's try it. We're still having that error. Oh, I didn't refresh. There we go. We have the blocks now. Now what we want, we don't want the width. What's up here now? We have 10 columns, maybe that's why. Let's try that. No? Okay. So the X position is having trouble. And the Y position. So the padding isn't having it. The width and the height should be fine. 40 by 20. Let's try making them smaller and see if that just makes it. No, because then they all. Snap. The padding. Maybe the padding's not enough. It's. I'm confused. Oh, snap. Okay. It's actually call times padding and row times padding. That's what it needs to be. There we go. Now that's what it is. So the padding was literally just kind of offsetting them. So if we do that, and we don't want height to be added twice. Wait, yes we do. I'm just gonna surround these in parentheses because, okay, you know what? I'm creating a var. var x equals, and I'm just gonna set it equal to this, and we will say that, and then we will say control x y var y equals, and we will pass that in. Let's do this and this, just making it cleaner. Plus width, and then we will say this. Let's drag it here. There we go. So now we have X, Y, width, height, and then the color. I think we can just kind of move this into one line. Yeah, there we go. So that's populating them. It looks good. One thing I'm gonna do, I'm not gonna worry about sizing them. I'm just gonna say var offset. And this, we need to calculate an offset for this to make them center because they have to be center. So it's going to have to calculate the rows and columns. Let's have var rows equal 5, var cols equal 5, or 4, my bad. Let's actually set it to 10. And then is less than rows. And then cols. There we go. Okay. So now all we need to do is offset it. Now we need to figure out, let me lose some of the padding. We need to figure out what this needs to be shifted to in order to be center aligned. So let's say offset is equal to, if each width, so we need to do width, we need to figure out what this distance is. So obviously width times, width times row, because we have multiple rows, width times rows, and that's just going to be all of the widths added together. You know, maybe it's plus width times padding. I think that's what it is. So if we multiply the width and the padding, and we multiply them, and from the rules of maths, we can just kind of do this. There we go. So that's the offset, kind of. It's kind of the offset. What we need to do is we need to actually, so that's just the width of it. Now if we have a width, here let me go back to this. If we have a width, something with width, and we have the width of the screen itself, we just need to subtract this one's width, you subtract this one's width from the total width. So that's going to give us a number like, let's say 100, because if this width is 200, and then we, or if the total screen is 200 and the thing we're doing is 100, then that's going to be this distance. We are trying to find the distance here and the distance here. Now what we need to do is divide that by 2 in order to get the padding on one side. So this will equal 50, and so now we know that this should equal 50, and you know, this will just be the rest, but it'll equate to 50 since it's going to be center aligned. So now that we have that, we actually need to do, okay, I kind of WH, and I'm just gonna KW because these are conflicting. These are some W, there we go. Okay, I think we're good. The width and the height, this is the actual screen size, and I kind of want that. So if we do, that's fine. We wrap these in that, and we just kind of add the offset. There we go. Okay, so we had something go wrong. Let's figure out why. We have 10 rows. Oh gosh, I'm doing this completely wrong. Oh gosh. This needs to be columns. This needs to be rows. Great. We want 10 columns and we want only a few rows. If we have this should be named, this should be H, this should be W. I don't know why hack was in there, but this should be W. This should be H. The offset should go here. And then this should be Y. This should be X, I'm pretty sure. Yes. Let's move the X above the Y because that's how it always is. Let's try it. Yes, okay. So now I'm pretty sure we have this correctly. That was funny how that happened. I completely disregarded that. So this seems fine. I'm going to figure out what this needs to be. What is this currently? Let's do console.log offset. And then let's read this. Offset is 240. So that means what we got here was 480. This seems right. Width plus padding should be 30 times rows. Oh, my bad. This should be calls. No, okay, we still have... Oh, no, not that. Calls. Okay, let me see. Moment of truth. It's center aligned. There we go. Now all we need to do... That took a while. Sheesh. Now all we need to do is tweak the width of these until they are... Okay, well, it's kind of center aligned. I'm not exactly sure why not. Offset, what was offset this time? 100? This is where it gets confusing. We had 100. The width of the screen is 600. So that means this... So we had, okay. This equated to 200. Which means this was 400. This ended up being 400. And that seems to make sense. Width plus padding. Width plus padding times the number of columns. That equals 400. So why is it not center aligned? Are we saying the padding? Because there shouldn't be any padding on the first one. I think that's what it is. I think there's padding on the first one. Well, no, maybe not. Because if column is 0, then padding will be 0. This is very odd. Plus width? Oh. I think that's what it is. Plus width. So let's see what happens if we take away width. It works. Let's see what happens if we take away height. It works. Okay. There we go. That's what was wrong. Now they're center aligned. Now, I guess you guys can't see it very well. There we go. I was just kind of debugging. But now they're center aligned, and that should have been obvious to me, but it clearly was not. Let's get rid of the logging of the console, and let's just stretch these out a tad more. Since they're 100 and we have 10 columns, we need the width to be... we have 10 columns, we need it to be 10 pixels wider on each one. With padding, let's try 14 padding. I don't really want that, actually. You know what? We'll keep this padding. We'll keep it at like something like 3. I think that's better. We'll make the width more, something like 60. Can we do that? Okay, then it's off the screen. I could be here forever doing this, by the way. We need something divisible by 600. So if we have, let's do 5 for padding, which will essentially add 5 onto the height. Now what we need to do is make this 55, and 55 times 60, that is a pretty equal amount. Let's make it something like 53. As long as the ball can't... There, okay, that's completely fine. I think that's good. Now, what we want to do is... We want them a different color, obviously. Let's do FFOOEE. I don't know why I do it like this, but that's looking good. Let's make it FFEEEE. There we go. No, I don't like that. FFEEOO. Okay, I could be here forever once again. So we're good with that. Now, what we want to do is check. This is going to be a bit of a longer one. Within handle ball, we are going to be looping through for var I equals 0, I is less than blocks.length, I plus plus, actually I minus minus, and we're going to have to do I equals block. I is... Okay, we're going to loop through it backwards because we may need to be splicing some of the blocks themselves if they collide. So, or do we do that there? Yeah, I'm just gonna do it like this. You know what, let's not splice them. We don't really need to do that. 0 I is less than blocks.length I plus plus. We need to say if blocks of I dot intact. So if it's intact, then we will check to see if the ball hits it. So if is colliding with here does collide, are colliding. If these two are colliding, and we will pass in the ball's coordinates and also the block's coordinates, blocks I, you see, okay, so the first one is always going to be the ball, second one is always going to be the block. So I guess what we could do is it's always going to be a block or a paddle. Here, we'll just do it like this. I think we're good. So if that happens, then we say blocks of I dot intact equals false. And that will make it no longer intact, and then we're good. So within this, we need to check if it is the paddle, if E2 is the paddle. What I could really do here is, and I may go back and refactor this code, but what I should do is have a sort of block entity and create the paddle off of the block, which is actually what I'm gonna do. It would make things much easier. So if we have var paddle, then we actually still need paddle velocity. Paddle is going to be equal to new block, and we will say that's going to be x. The y, oh man, felt something on my tooth. Wow, that felt weird. Height, just randomly out of the blue, I have no clue why. Width and a height, so the width is 100, height is 10. We'll do right here, we will say paddle.x, paddle.y, paddle.width, paddle.height. And we will make the color FF. There, okay. cool. Now the color really shouldn't matter. But we'll do it. We'll do it. Because why not? Paddle.c. There we go. And we have an error. Okay. It's not a valid color representation. Did I have one too many? No. 1, 2, 3, 4, 5, 6. Sketch, draw, or fill, paddle.c. So we're having trouble at paddle.c. 1, 2, 3, 4, 5. Do I have 5 in here? Let's see. 1, 2, 3, 4, 5. Apparently this is incorrect. I'm going to try that. We still have an error. It's a block. Let's do console.log paddle.c. And let's move this upward. There we go. FFFF. And then it changes to undefined for some reason. So why is that? Do we get rid of ball for some reason? It changes to undefined for some reason. The second loop around. So what do we do? What is this? Did I accidentally do something wrong? Here. Paddle. Let's try. Here. Find. I think what we do is we set, yeah, that's what we do. So what I need to do is say paddle.x, and then we say paddle.x equals constrain paddle.x. That's where I set it. And now it's working. Okay, let's actually delete the console.log, and let's exit, and let's check to make sure everything's good here. Okay, neat. And the ball flies in nicely. I didn't mean to do that. Now, what I need to do is take a sip of water. Now what I need to do is handle the collision and say if okay, let's actually let's add blocks dot push paddle, and what I need to do is move this, nope, there we go. We're gonna just push the paddle. No, we're not, my bad. I'll keep that there. Outside of here, we're just going to check for the paddle. So if are colliding, let's say if are colliding, then you know what, actually yes, the paddle is exactly, it's just a block. But we don't want it changing. Yeah, we don't want it going not intact. So we'll just say break. So that will be that. When it collides, we also want to say ball v dot y, right? Yes, times equals -1. So we inverse the y, and then we say if are colliding, and we'll check ball with paddle, because it's going to be the same thing as this, except we won't be saying intact equals false. And I could have done this much better, like object-oriented, but I didn't have the planning beforehand. So if the ball and the paddle collide, then we want to say ball v dot y times equals -1. So that's the collision between the ball and the paddle. Now what we need to do is we need to check the ball's velocity. Yeah, I'll just keep this E1. No, yeah, we're gonna say block. There we go. Okay, now what we do is we say if ball dot x. No, let's say ball dot y is within the certain area of the block itself. So if ball dot y this is odd. Okay, so what I need to do here, I'm just going to, let's say control new, nope, control new. Why can't I just kind of move with the, okay. So what I need to do here, can I get a square? Give me a rectangle. Oh, no, I always do that. There we go. Let's fill it with a cool color, like gray. And then we will create a ball. And let's put a ball here. There we go. Should be good. And we will fill this one with green. Okay, so this is going to be kind of difficult to explain. I don't really know how I should do it. So we have the distance, we have a radius, and this is the point that we're calculating everything. Essentially, I guess what we need to do, now that I think about it, is get this point and this point. Here, I'll make this point a bit bigger. That point, that point, that point, and that point. So if you get these points, this will be x comma y. That would just be x comma y. This will be x plus the w, and then y. And then, you know, I'll just make these just because it'll be easier to think about it, plus the height. And then this one will be x plus width, and then y plus height. So what we need to check, essentially, is if the distance, well, we need to check if this point plus its radius in all directions, if that ever falls within this. Here, okay, so if we check the radius, or if we check the distance between this and this point, yes, okay, we need to check the distance between this point and this point. Or actually all the points. And if any of the distances come up less than the radius, then we've hit it. But we kind of would also have to do that for all of these points on this plane. So what we want to do is check we will have to check a plane at a time. So we will get the x, we'll check the x, we'll check the x plane and see how different it is from this point's x. We'll calculate that distance, and that will give us some number. I'm not exactly sure. If it's up here, no, okay, let's start with the y. So if we have a, oh gosh, that looks odd. If we have a circle and we have the radius, the distance between a point like on the thing itself right here, this will be the y value. So if we get the y from this and the y from this and we subtract them, then we're gonna get that distance. So if they're less than, if it's less than the radius, then we've hit it. And And I guess we need to check for both. The y and then the y plus the height. So let's try that. If block.y, let's say block.y, is, okay, here, math.abs block.y minus ball.y, if that is less than the ball's radius, which is, it's 20. Well, that's the diameter. I think that, well, I'm not sure. I can't remember anymore. So, if that's true, here, var top equals, this, here, we'll do C top, CW top, colliding with top. Colliding with top, and let's do the same thing, var colliding with bottom equals, and it's going to be math.absolute value of block.y plus the block's height minus the ball's y less than 20, colliding with bottom. It's not technically colliding with it if those are true. We just kind of have to check that later. So if it's colliding with top or colliding with bottom, then we will check x values, x plane. Okay, and we will name this check y plane. So that's what we're doing. We're checking the y plane on this. And that's essentially what we're doing here. We're getting the distance, we're subtracting it, and we're doing that for the top and bottom. And if either one is less than the radius, then we know we are, then we know that we are touching it. So now we need to do the x values, and that's going to be essentially the same thing. So var collide with right equals math.absolute, and this is going to be block.x minus ball.x, and we're going to say if that's less than 20, colliding with right, and then we will do var collide with left. You know, I think we should do left first, but I'll move it afterward. So if we do block.x plus block.width minus ball.x is less than 20, and I'm not really thinking about it, but I just kind of made up the function and we should be good. So let's move this one on top of that one, and let's shift back here. So if it collides with the x-plane or the right plane, if see, now this is odd. We're checking if it collides with the top. So if any of those planes are the same. Okay, we need to change it up a bit. It's not the same. I lied. I'm just gonna put this in so I stop getting the error, but we mess this up a tad. So we check the y if it's on the same plane as the y, or if it's in between the y. You know what? I did this completely wrong, I think. What I need to do all I need to do is check if, oh goodness, this is difficult. Okay, let's look at it a different way. We have 2 planes. Right now I'm looking at just the y planes. And then we have a point, and we have the surrounding area of that point. If this point, so we have the block here. Okay, so I think I figured it out. We have the point, but really the whole block has this invisible, we can think of it as a shield or something. So if this point lands between any of these y values here, like any of these y values within these green lines, that means we might touch on the y value. So that's what we need to do is we need to check the y plane, and we need to find the bounds of the y plane. So what we do is we have to get this number, and we have to get this number. This number will be, let's see, var bounds equals here. We'll say upper y bound, and then this will be this plane. This is difficult. So that will be block.y, and then var lower y bound equals, and then, okay, this, I lied. This will actually be block.y minus the radius of the ball. So minus ball.r. No, minus 20. Now, this one will be, because we're going off of this line. When we say block.y, we go off of this line. That's why I had to subtract the radius of the ball, and that gives us this one. Now we have to add the height of the block along with the r again. So minus r plus height. So let's add the height and the radius of the ball. So block.y plus block.height plus the radius of the ball. If we had here, I'm just gonna say radius. var radius. Okay. Here. Let's say radius. Oh, my bad. This should be here. Radius equals 20. And I think that should be good. Where do we have 20? Where all do we have 20? Radius, radius, and we really don't need to do that. So if ball.y lands between these, so we need to check if it's between. So how should we do that? So if it's got to be greater than the upper bound, because we're thinking inverse type things, because this is up here is 0 and down here is 100. We increase that way. If we have, it's got to be greater than or equal to the upper y bound. So if block.y, here, I'm gonna move these. Actually, let me just do this. Block.y, or ball.y, that would be bad. If ball.y is greater than or equal to the upper bound, and it's also got to be less than or equal to the lower bound. So lower y bound So that means it's on a point in the y space, so that it will essentially need to be it will need to be reflected off of. I guess it's at a y value where it could hit it. So we just kind of check the y value first. Now if we check the x values, now we have the x values. So let's look at the x values. We have an x here, x here. This one's going to be x, and then this is going to be that. Or that, you could think of it like that. This is an ugly yellow. So now we have to check if it lands. If it lands between these two. I guess. That's what I'm going for. Okay, so if it lands between those two, var left x bound, it really should be leftermost, equals block.x. Okay, actually, minus the radius. Didn't mean that. Var right x bound equals block.x plus the block's width plus the radius. So that's the rightermost. Now, if it lands between those, meaning ball.x is greater than or equal to left x bound, well, no, yes, and ball.x lands in, or less than right x bound. Collision. And let's console.log all these values. Upper y bound, lower y bound, and then we will log left x bound, and then right x bound. And then we'll also console.log ball.x, ball.y. There we go. That should do it for the logging. Now if that happens, we need to invert one of them. You see, this is the odd thing. If it strikes here, then we just kind of inverse the y. If it strikes here, then we have to inverse the x. If it strikes either of the sides, then we inverse the y. If it strikes the top, then we inverse the y. If that made any sense. So we need to check which way did it hit. So if it lands between these y values and these x values, that means it's somewhere around here. So essentially what we've checked for is whether what have we checked for? We've checked if it falls, if the ball is anywhere here, anywhere within this space. If the ball is anywhere within this space, then we've collided with something. That's fine. Let's say we need to return true, and we also need to say and here we will say return false. So that's fine. We know that it's collided. Now we need to handle the reflecting it. See, this is where it gets real weird. If it lands, So we first checked the y. I guess if the y is anything within the radius of the block itself, then we know we've hit a side. If not, then we've just kind of hit we've hit one of these. So that's how we'd know. We need to handle deflection. It's not reflection, it's the deflection. So we need to check if the ball is at any depth in the y, that would mean it has to be, okay, so obviously if it's in here somewhere, like if it's any closer here, that means that we haven't already checked the y value for being out here. So this position is it's essentially impossible, because we will always have checked right here before that and reflected it before that. So that means if anything falls here, if anything falls within this space, that means we have to have had hit a side. So that's what I'm checking for. So if we do block.y plus, or block.y is, you see now it's weird. It's very weird. Here, if it's less than, or if it's greater than the y, not greater than or equal to, it's got to be greater than by a few points. We'll get some of that in a little bit. So if it's greater than that by any amount of points, if this is true, then that means we need to hit it from the side. Here. It hit the side. Else, ball hit, on y plane, and let's change this a little bit also. Ball hit on x plane, ball hit on y plane. That means the ball velocity dot y, if it hit on the y plane, we need to invert that. Hit on the x plane, then we'll say ball v dot x times equals -1. So we need a little bit of leeway in this. So we'll do math.abs is less than 5 pixels. Let's just say 5 pixels. So if it's less than 5 pixels, if the ball.y minus the block.y is less than 5 pixels, then we will say that it hit on the x-plane, which does make sense. So let's try 5, and then instead of having it like this, we will have it like this, meaning it might kind of hit the corner, and so we'll do it a different way, depending on that. Ball hit on the x-plane, ball hit corner, and we will say do both. Ball v dot x times equals -1, ball v dot y times equals -1. So if it's less than 5, let's do less than 10. But if it's less than 5, then we'll say it hit a corner. And that should be fine. I don't know if this is going to work. Okay, we had an error. Ah! What? Oh, that's sick. Okay. We had it work for a sec. Nice. Oh, that's insane. Okay. Oh, that's so cool. Dude, it feels so good to have it nice. Oh, this is insane. Okay. So that's good. Okay, wait. I don't want to be reflecting that one. It's thinking it's hitting on the... It's thinking it's hitting... Whoa, that's crazy. Because sometimes it breaks more. So if we have... Here, I'm going to space this out a bit better. So this is happening a lot, where it's reflecting twice. So this needs to be less, and that needs to be less. Let's try this. There we go. That kind of... Here, okay. We had a weird... Okay. It's still reflecting incorrectly. It's still thinking it's less than that. Oh, wait. No. If the ball's Y, it's less than 3. Okay, these actually need to get bigger. So let's try, like, 9. Actually, we know that 10 worked. This is the one that we're just gonna have to try and fiddle with. Oh, I missed it. No, we're still... Yeah, we're still having that. So if it's less than that, yeah, okay, we can just kind of let it go. And right there, it's not wanting to do it. It's only on a corner. This is odd. This is very odd. This one is firing too often. It's... This one's firing too often. I guess it means this needs to grow? No? So we have that. This is very odd. This is a thing with game programming. Let's try to hit it on the side. Okay, well that kind of happened. Okay, it seems that it's only really picking up the sides of it, or the edges. So we're having trouble. If it falls between those two bounds, then we're good. So we need to log it. Here, let's actually... I already have it all logged. Let me do this. Okay, so that happened. If I could freeze the frame. Okay, here, this is what I need to do. Real quickly, I'm going to add function on key press. Here, let's go here. This is a long episode. Key press. Key is pressed on key press. Events on key press. Here. Mouse pressed. Function mouse pressed. No loop. Yes, okay. Can I say continue the loop? No loop. Here, okay. Loop, okay. Can I say is looping? Can I check if it's looping? Here, let's create var in-game. And we'll set in-game equal to true. And then we will say on mouse pressed, if in game, then we will say no loop, no loop, else no loop, and we will say in game equals not in game. We're good. There we go. I'll use this to debug. Oh, my bad. Oh, we're having trouble. There we go. Okay. Here we go. This is what I'm looking at here. So when we logged it, we have, where did we log it? We log it here. We have the upper bound. My bad, I accidentally added a space. Upper bound and the lower bound. So that makes sense. We have the left x bound and then the right x bound. So that makes sense. Okay. And then we have the balls x and the balls y. So what we have the ball landing in between these. So that's why this fired. That's why all this fired. And we have the left bound running. And that is because 270 lands between 160 and 300. That makes sense. So it's landed in between those. Now what is happening is everything's good here. Except here. This doesn't like to work. I'm not sure if it's not colliding or what, but we'll check that later. We'll address that in a little bit. So if we look at the difference between ball.y and block.y, this is simply okay, wait. Upper y, ball y minus block y. If that's less than 20. Oh, my bad. Right? If it's less than 20, should it be greater than 20? Let's try this. I think I might have messed up here. Okay. So that happened. Oh snap. Whoa. Okay, here's where it gets kind of funky. So we have it colliding. Here we go. I guess, why? Okay, it's saying it's colliding. We have a collision. One of these should be running. If that, else if that. Let's check something like 5 and 3 again. I'm not exactly sure. These are things that looks good. Oh, yes. So if it's less than 5, then we're good. Let's check less than like 3 and 2. Okay, well that did that. It's reflecting too often again. So we're saying if it's greater than 3, it's also gonna be greater than 2. So that happened. This happened. 310. 310 on the Y, 40 or 340. Okay. You know what's happening? It's not actually the radius. This is not the radius. That might be contributing to it. When we draw it, we need to multiply this by 2. That's what it is, I'm pretty sure. Oh, here, okay. Well, I mean, okay, well. Oh, didn't mean to do that. No. Alright, okay. Okay, no, there. Here we go, got the data. 351, it does indeed land in between these two. So that makes sense. So what I don't get is why it's reflecting incorrectly. It thinks it's hitting the corner. So maybe what I need to do is change this, change that to that, change that to Y. Maybe it's as simple as this. Let's get rid of this, let's get rid of that. Oh, well. No, it isn't. Or is it? What happened there? Oh my goodness. No. No. Oh gosh. This is a struggle. Okay, there. Got it. So we have 351. We're good. We're good on that. It doesn't seem to actually be reversing. Oh. Wait. No. So if that happens, then we say it's reflected. So what I need to do then is check the ball's Y. So let's see what if I did this. Ball velocity dot x. What if I added ball x plus, here, we'll say var bxv is going to be ball dot x plus ball v dot x, and then var by velocity is going to be ball dot y plus ball v dot y, because I don't think it's taking into account the velocity of the x. So if we do ball xv and we say ball, oh, didn't mean that, bxv, and then we change this to byv, and then we say that, and we say this. Okay, cool. Looking good. Okay, well that kind of happened. Oh, my bad. Okay, you know what? You know what I want to do? Ball xv, ball yv. That's what I want to be logging. Let me get a good... Here, let me turn this off, and you guys can watch me struggle. You know what? I wanted a better one anyway. Here we go. We had the ball reflect. How many detections do we have? We had 1, 2, 3, 4, 5. And that's not what we want. We kind of just want it to detect once. I'm guessing that's because we let it go through and we didn't actually reflect anything. What we really need to do, we've added the velocity of the ball. Oh! Wait a minute. Oh goodness, why is it wanting to do that? Okay, now it's not detecting anything. I don't understand. Let's just do this. That's what I needed to do, right? There we go. Ah, nice. Okay, let's see. So it's not keeping the X, but it is only detecting once. Huh! See that? Okay. Okay. I'm having too much fun with this. Okay. We got a good one. Why did that deflect that way that time? So 350, 352. So this is what happened right there. 4, 3. This should be happening more often, I'm pretty sure. Oh snap. Oh, there we go. Oh snap, why is it doing this to me? There we go. Okay, I think we're good. Yeah, I think we're good. Okay, so, well, that time, no, it did not want to do it. That time it did. That time it reflected correctly. It went to this one. Let's check that. There we go. There we go. I think we're good now. There. Looking good. Uh-huh. I'm liking it. You know what we could do? I think what we can do is ask this. Here, let's just do that. And we'll draw it before we check the collision, I think. Yeah, I think that makes it much better. There we go. There we go. Okay, cool. Now what we really need is an array of static. Okay, so that likes to do that. What we need now is some static, let's see, obstacles. Okay, and then obstacles, or bounds, kind of. Static bounds. Actually, okay. Here. Static blocks. Now if we say, we gotta say static blocks dot push, and then we're gonna say paddle. And then we're going to push some new blocks, which we'll do in a second. But real quickly, we'll do for var j equals 0, j is less than static blocks dot length j plus plus. My bad. J plus plus. J plus plus. There we go. And we'll do. Wait, this is draw. Don't want to do that there. My bad. Had it in the wrong loop. Handle ball. Here we go. If are colliding ball and static blocks of I. And so the static blocks will be filled with the paddle. It's also going to be filled with the roof. So we need a new block at width, or actually 0, comma 0, and then height, and then let's see. It's not actually going to be height. It's going to be 0. You know, we'll make it like 1 height, just because. And then we'll make them. There we go. That should be good. Left, and we'll say right, and then we will say top. This is going to be 0, 0. Now this is going to be width, comma width, or not width, it's going to be width and then 0 and then width comma height. We'll do width minus 1 just to make it a couple of pixels on screen. And then here we will say 0, 0, and then 1 width. Oh snap, I messed this up, right? No. This is still gonna be, this is gonna be 1, this is going to be width. There we go. So now we should have bounds. Except we kind of had a oh my bad. Static blocks equals that equals a new array. Cannot find property y of undefined. So where'd that happen? It happened. Can I exit out of this? I'm not sure. Anyways, let's open this up a bit. Here we go. How do I exit out of these? There we go. Hide navigator. Okay. Block.y minus radius. Why is that happening now? Handle ball. We have all these looking. Oh, that's why. That was a dumb mistake. Okay. Let's try this. Okay. There. If it hits a side. Okay, yes. Okay, and that hit the bottom. I want it to hit a side. Okay, what we need to do is make it hit a side. Let's see. Oh, it hit the top. Yes, that's exactly what I want. Oh, no, okay, there. So it hit the top. We're just having trouble with we are having trouble with the sides of things. And I think the bottom of things too. Let's test this. Since this is kind of here, I'm gonna make it like 3 pixels. And it's kind of a border. Let's make this 0, 0, 0, 0, 0, 0, 0, 0, 0. Just so I can see them. Okay, no, we cannot see them. Still 5 pixels. This should be able to see them now. Oh wait, no, I'm just not drawing them. Okay, yes, we do have an error. Now what I want to do, I want to be able to say, okay, what's wrong about that is this is happening. That's what's happening here. Okay, well, that happened. Didn't want that to happen. Nope. Still not having it. Let's try that. Oh. Ah, bro. Oh, neat. Okay, well, that happens. But we also have this odd twitchy thing with that happening. But it's working. We can definitely see the ball moving, and it kind of fixed the bug with the what's it called? Ah, this is fun. Ah, I'm hyped. Let's see. Oh snap! It's doing some cool things. Okay. Well, it kind of jitters a tad. I think we're fine though on that respect. It when it hits the Y value. See there, it hit the corner. That's really cool. I like how it did that. Maybe this, cause right now this is saying it hit a side. That's what it's saying. The Y hit a side. I'm gonna keep that. hit on X plane. This is saying hit corner. When it hits on the Y plane, that's when we're having problems. So if this is, what is it that's making it do this? I don't truly understand. Okay, well that was odd too. Well, it's doing good with the corners. I think it's doing too many corners. I think that might be what it is. Okay. Oh, okay, no. Yeah, we're having some odd things happening. Yeah, okay, let's see. That'll just be like that indefinitely. Let's try 3 pixels. See, it's thinking it's hitting the corner every time now. Which it's not. I don't think it is. Let's... Huh. This is confusing right here. If it's greater than 3, that means I don't think this honestly needs to be the absolute value of it. Oh. Okay. Well, that happened. Can I just leave my paddle here? And it's gonna do that forever now. Oh, snap. Oh. Oh. It should be block.y. Here we go. Oh. What's wrong here? Oh, that's wrong here. Okay. So that was an error on my part. Okay, we're still having that odd error, or not error. Yeah, okay. There we go. Okay. That was a good... Oh, no. There we go. Okay, F12. Let's debug. The ball's velocity is this. So this should not have run. I don't understand why this happened. Oh, wait. Huh. What we need to check... I don't think we should keep doing block.x minus the ball velocity. If we do that, then that would have been... What is 3? Because we're saying lower y bound, upper y bound. And it was very close to this one. Or no, it wasn't. What was block.y? Here, we're gonna console, and we're gonna say block.y along with these, actually. Plus, it's not that late, come on. Okay, let's see. Let's rerun this. Well, okay, let's get a better one. There we go. Let's check. The 360, that is the actual y coordinate of our paddle at that time. So we're doing, if the block's y minus the velocity is greater than 4, well, we need to be checking if it's try Pac-Man. Oh snap, that's a big game. So we had the ball's velocity at 350.388. and that meant that it was in between this. And then we checked the velocity. So this minus that is 10. And we didn't want to... Okay. What we need to do is, if it's greater than radius plus some amount. Radius plus a little bit, like 2 or 3. Let's go for that. Or 4. Let's go for 4 since we can divide that easily. So if that happens, then we can also ask if it hits from below. So the y value will have been block.y plus the width of the block, or the the height of the block. If that minus byv, this needs to be capital, is, what will this be? So now we're checking if this point plus this point, you guys can't see it, we're checking this point plus this point minus the ball, which should come out to be, let's see, if we have 0 and 50, here, I'll paint this. Oh goodness. Don't save. Right now, we will, oh, didn't do that. Nope, there. And I want a rectangle. Nope, I wanted a rectangle. There we go. Let's fill this. Let's make it nice. And then let's add a ball. Let's add a ball here. There we go. And then, did you guys see this? Here. Well, I guess it makes sense. But truly, it really doesn't make sense. You can rotate. This is fun because it doesn't change. Anyways, okay, so let's do that. And we will fill this with something also. Something like that. That's fine. Now, what we will do, I will do Pac-Man. I will do that. So let's say this is at like 50. And the width, or the height, is 10. This will be 60, obviously. And then the velocity will be this point. Plus the radius, I'm pretty sure. What do we even have the oh, wait a minute. No, we're good. So with this one right here, this line, I checked if essentially what I was checking was if this is here and the distance between this point and this point is greater than the radius plus 4. In reality, it needs to be less than the radius. I'm pretty sure. That's what the top one will be. Now the bottom one will be, what will that be? I'm trying to figure out the bottom half. What if it strikes the bottom half? This will be 60. So if this minus the ball's velocity, which is going to be greater, that will equal negative. And I don't necessarily want a negative. So I'm going to reverse this. byv minus, and we will put these in parentheses. And then we will check if that's less than the radius. So when this happens, if either one of those happen, that means we struck it on the y-axis. Ball hit on y plane. I'm gonna ball hit. Okay, so that should be with the ball hitting on the y plane. Let's go back here. There we go. Okay, so this is working fine, except we don't want to be reversing the x. We only want to reverse the y. There we go. Okay, so that's happening. There we go. Let's check the console. 360, everything's checking out. Here we go. Okay. So now, what needs to happen, if it didn't hit that axis, then we need to check if it hit that one. Really, what I think I'm going to do, I don't think I'm going to have the else. I think I'll just have it hit on the x plane. I don't think I'll do this else if statement. I think I will only do that. So let's try this. Oh, no, we are still having that problem. So here's what's happening. The bound, okay, here, I'm gonna move up here. Here's where we're having trouble, it seems. The bound, or the y bound, okay, we're cool with that. We're finding the y bound, which means, what are these numbers? It hit, and then it just kind of goes crazy. I'm not exactly sure. So it hit this, and the upper bound should be different. I don't know why this bound is showing up here. I don't honestly know what bound that is. And it only appears once. Oh, that's my paddle. My bad. Oh gosh. Here's where it's happening. So we have the upper and lower bounds. Here they are. Now we have the left and right bounds, which makes sense. So it struck the bound. It struck it. And what we need to figure out then is it's so odd. It's so odd. Maybe it needs to be greater than the, I'm not exactly sure why this is happening. What I think now, yeah. Let's keep these less than. Let's see what happens first if we hit one of these. Okay, we have a problem. I don't think this is working right there. Let's try this. Okay, well, no. Yeah, okay. What I think is happening now, since we are checking if the ball's velocity, or if this minus the ball's velocity and position is less than the radius. So we're saying, say this is something like 80. 80 minus 60, let me do that. If that is less than the radius of the ball, which is 10, then what would it be then? So if that happens, what we really need to be checking seems to be, I don't know. Because we're saying 80 minus 60. Let's pick better numbers, like 80, no, let's do 55 minus 60, which will mean essentially that it's somewhere here. If that is less than 10, here, let's put these into separate blocks. here we go. Let's do this. Else if, there we go. Console.log. I'm just gonna say hit bottom, and then hit, nope, console.log hit top. Let's try this, and let's reflect it each time. Let's comment this out, and let's see what this gives us. Oh, nope, not that. Not what I meant to do. Okay, C. It hit the top. That makes sense. So it hit the top. So what if this had been greater than that? Then we would have gone to the else if this wasn't true, if this weren't true. So what signifies that it's true, really? We say block y minus the velocity of the ball, which the ball would probably be, the ball would have to be greater than it by its radius. It's got to be out here somewhere, greater than it by its radius. So what we have now, if it's less than it, that's when we need to be checking this. If that's no good, then we've hit on the x-axis. Dude, this is very odd. Oh, nope, we still have that error. Hit top, hit top. It hit the top again? It's saying it hit top. If it's less than the radius, then that means it hit on the y-plane? If that happens, then it means we might have, I don't know, maybe I just messed this up. If it's less than the radius, then it means, here, let's give it some leeway. Radius plus 5. I think that should be good. Let's try it. Oh, no. Okay, no. So now we're just reflecting. So that's not what we want. Ball Y, if it's less than the radius, that should mean it's not hitting it. Dude, this is so confusing. If I could draw it out, it'd be good. But I can't really draw it out. So this is when a chat is helpful. If anybody's a game programmer in the chat, let me get another water bottle. Okay, there we go. Let's see. If it's less than the radius, then it shouldn't mean that it hit. It needs to go through another check, I guess, to check if it actually did hit the ball or the top. So if it's less than the radius, that means it hit the top. But if it's somewhere down here, then we need to check block.y minus byv is what? Is less than 0? Then, and only then, we will check here, okay, there, and that hit top. If not, we will have to see. Here, let's do this. Oh, my bad. Whoa. Gosh. So that time we had some interesting things going on. We never did anything with the x value. So I don't know why the x value changed. It should have hit the top there. Okay. That's why. Okay, so that time it worked. You didn't see it because you can't really see what's going on that side. But it hit the top and we're good with that. Now let's try this. Ah, nice. Oh, didn't mean to do that. Okay, yeah, that's a bug. But it seems to be working now. Okay, well that kind of happened. No. Okay, let's try this. I think the width of the paddle really just kind of needs to be lessened. Okay, well, I think that's all, really. I don't think any of these are happening. Yeah, I don't think that was even a problem. No, wait. I might have just broken it. Let's see. I don't really know if it's reflecting correctly. Oh gosh. Why does it do this to me? Come on. Can you find a different place to not go? No, stop hitting the sides of them. Okay. Yeah, it's reflecting incorrectly. This is weird. Because the only place we have it reflecting all... Wait. Huh. That could have been messing us up the whole time. There. 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 Yeah, it only changes the X, which is not what we want. Here we go. Okay. I think I figured it out. Let's do this. Let's keep that. Oh, this needs to be a capital Y. This one needs to not be there. Okay. And what we've checked now is if it hit the top. Okay, right now it's only checking the bottom. So if that happens, can I say this now? Here. So this obviously isn't happening. This one is always happening. It is always saying that. So if it's less than 0, then we need to change the x-axis. Okay, this is so odd. This is so weird. So let's try this. If that happens, then we'll say here, we will delete these, and we will delete that, and we will say console.log hit 1, and then we will say ball v dot y times equals -1, and then we will say else console.log hit 2, you will say ball v dot x times equals -1. So that happened. It's hitting 2, which is fine. Let's see if we reverse this. Let's try reversing all these. So it hit 2. That's good. Ah, okay. Let's see. Hit 2. Neat. So it hit 2. Now let's see. And we have errors there. It's never hitting 1. So this is always true, so that's not the check we want. What is the check we want, then? If it's less than the radius, it's also got to be... Let's try less than. Just because... So that time it hit 1. So if we do y, and now x, hit 1, hit 1, hit 1, and then it keeps on hitting 1. This is still never firing. Never is it ever firing. Huh. I should have drawn this out a bit better before starting it, because now it's just kind of a massive headache. What am I even doing here again? I'm checking the bottom, right? Yes, okay. So let's try this. I'll keep that there. And then I'm going to comment this out. And then I'm going to do if. And we'll try that. Okay, there. Here. Here we go. Not that. F5. Here we go. So it hits 2, hits 1. Let's try less than 5, just because we should. Okay. Hit 2, hit 1. It's always hitting 2. Let's try 10. There we go. Is this just radius then? Okay, let's see what happens when it does that. Yeah. Okay. Hit 1, hit 1, hit 1, hit 1, hit 1. It always hits 1. I don't understand this. Let's try this a different way. Instead of saying Pac-Man, you want me to do Pac-Man next? Alright, let's see. I don't know if I'm going to be able to do that next, but we will we will check. We're having the same look. So what is even happening here? It's only hitting 1. So this is always true. This check is useless right here. All of those checks are useless. Let me do this. Handle deflection. This has been the struggliest struggle. How do we know if it hit the side? That's the question here. If it hits here, then we reverse it. What is the I'm trying to figure out why it'd be doing this, or how you could check. We could check which range it's in, kind of. See, this is when I kind of rework the whole hit detection, or the collision detection. Here's what I'm thinking now. Here we go. We have a rectangle. This is a paddle. This is whatever you want it to be. I think I'm gonna have to rework literally everything. Not exactly sure though. Let's do this. So we have, yes, okay, that's what I want. So we have sides. We have sides and everything. It's all nice. Okay. What we're trying to do is see whether it hits a side or the top. Dude, this looks so odd. It's so blurry that it kind of hurts my eyes. There we go. Here we go. Gotta get a little bit closer. I'll do here now. Haha, nice, nice. Let's get some blueness going on, and you'll see what I'm about to do in a little bit. That's too light of a blue. Let's go for the dark blue. Kind of looks like America. I'm loving it. Hang on. And here we also have some points. And here we also have some points. I'm just gonna have to rework the whole collision detection. Okay. My screen is shaking because I'm going up and down. So, we have a circle somewhere here. Somewhere. And if it collides, that means it's gotta be around here somewhere. Really, we have a second rectangle. We will have a second rectangle. And then this is the sweet zone, right? Oh, not what I meant to do. Right there. Let's fill this in with a separate color also. Green should be fine. No, okay, I'm not going to. So, all of this out here is fine. The green will represent that it's completely fine. If we can paint bucket all of this, nope, okay. Nope, okay. How are we gonna do this then? Paintbrush? Oh, that looks so odd. All of this is fine. All of this green space, completely fine. The ball is allowed to go here, and there is no collision. Oh, didn't mean that. So, really, what I'm thinking now is instead of having... Oh, gosh. Instead of it checking all these things, I think we should have 4 quadrants. Maybe some sort of quadrant for the right, some sort of quadrant for the bottom. And these will span on the corners too. Maybe some on the right, and this will span over here. And let's do something like, I don't even know, orange looks neat. So if we do this, here, they overlap with each other. And I think what we need to do is check if the radius, and essentially this is where they should go. I kind of messed that up. We have a quadrant here. We have a quadrant there. We have a quadrant here. And a quadrant here. Okay, this was a disaster of a painting. Is there a selection tool? Can I select? There, okay. Here, okay. There we go. Oh, didn't mean that. Okay. Let's select here. Delete. Nope, not what I meant to select. There we go. There we go. There we go. Here's what it is. Here's the coordinates of the block itself. Okay. This is what I'm doing. I'm deleting all of this. Right? Yeah, I'm pretty sure I need to delete all of it. Not all of it. I'll see what I can keep. So, we also need var upper y bound equals block.y var okay, lower y block here equals lower e block, lower y bound, upper y block. Okay, upper y block, and this will be block.y plus block.h. So that's what this is. We have upper y bound and upper y block. Didn't mean to do that. Every time. We have an upper y block, upper y bound. The bound is this part. The bound is the outermost square. The block is the actual block itself. We have the velocities, which are nice. So, we need to check var within top bound equals whether or not byv is greater than or equal to upper y bound and byv is less than upper y block. So that's what I'm doing. I'm splitting it up into quadrants now. Since we have a rectangle, essentially what I'm going to be doing now. Here, let's delete most of this. Here we go. Okay. Let's delete some of these, some of these, some of these. Let's do var within low bound, here, within bottom bound, equals whether byv, it's got to be within here. Whether byv, it's got to be greater than, or it's got to be less than the upper y bound, and it has to be yv, I need to capitalize some of these y's, is greater than or equal to, and then this should be lower y bound, lower y block. This is getting really complex. So I'm checking here. I'm checking right here. I'm asking, is it within the orange part? The orange part spans this, just this part, or in theory it should. So if it's within one of those bounds, then we might have to reflect it. Let's continue doing some of this. Okay, here's where we check the y-plane. And let's do... Snap, this is some crazy collision detection. Check x-plane. Now, what we have to do is var left x block equals block.x. var left x bound. Now this is going to be equal to block.x minus the radius. And then var right x bound equals block.x plus block.width, or my bad, this needs to be right x block var right x bound equals block.x plus block.width plus the radius. So that's what we have right now. And then we have var within left bound, and that is going to be equal to whether or not, we need multiple checks for this, whether it is within the red. So the red is going to be the left bound. So the bx needs to be greater than the bound. Let's see. bxv, it's got to be greater than left x bound, and it's got to be bxv less than left x block. Here we go. Okay, var within right bound. I named this incorrectly. This is going to be bx velocity. It's got to be less than the left or the right x bound, and it's also got to be greater than the right x block. Okay. All of those calculations are out of the way. I'm not even going to be logging this because this is some crazy stuff. Okay. So we check ball's true velocity. So now what we have is a Boolean. Whether it's in the top bound, whether it's in the bottom bound, whether it's in the right bound, whether it's in the left bound. And that, now we check the x. We don't have to worry about the radius at all now. So what we need to check is if it's within each of the bounds. So obviously if it's within top bound, let's check within top bound, because we need to check top bound, bottom left, bottom right, bottom top, whatever. We need to check all of the corners also. So if it's within the top bound, else if within bottom bound, else if, and then else if, dude, these are so crazy, within right bound or left bound, within right bound. Here we go. If it's within the top bound, then we will say it hit the top, and then ball v dot y times equals -1. If it's within the bottom bound, we do the exact same thing. If it's within the left bound, we say ball velocity dot x times equals -1. If it's in the right bound, we do that. So now we need to try it. Oh, okay. So we have, what is going on here? Okay. This is odd. We have a ghost. We have ghost here. If it's within the top bound, then we reflect it. Oh, wait a minute. Okay, well, if it's within the top bound, we don't really have any sort of, oh gosh, this is very odd. What it's doing, it's only colliding within this plane. If I did this, yeah, now it's only colliding in that. So what we need to do really is check within bottom bound or within here. If it's happening in the top bound, then because okay, now this is weird. So really what it's doing, it's not like this. Really what's happening is this. This is extending here and here. This is extending here and here. These are extending upward also. Like this. And then this one is extending there and there. So really what we want to check is whether it's hitting top bound, right bound. So if it's hitting any of the bounds, which most likely it will be, but we'll check top bound. Okay, what we're doing is going to check top bound. And if it's hitting just the top bound, then we're saying and not here. Let's just say, let's rename some of these. Top bound R L T B. So if it's in the top bound and it's not within the left bound and not right bound, then we can safely say that it needs to reflect. Okay. Then it just reflects on one of these axes. So top bound or left bound. Did I accidentally name it incorrectly? Left bound? Oh, here. Okay. So if that happens, we're like, okay, we can do it on the Y. Let's see. There we go. We got a ricochet. We're good on that. So else if now it could be left bound. Now it could be left bound or right bound, but not here. Okay, wait. They both gotta be false, so we could have an or, but not both. And top bound or bottom bound, but not both. And then we say else if, well, okay, so if this happens, then we say ball v dot x times equals -1. Else if, and now we say left bound, we only want one of them. So left bound, they can't equal each other. So if they equal, then we're wrong. Right bound. So if they equate to each other, then we want it to have false. Or if they equate to each other, then we don't want it. However, if we also want this. We also want top bound and bottom bound. Let's just use not equal to. So if this isn't equal, meaning no, that's not what I'm asking. Let's not worry about this for now. Let's check this. Okay, we're good. Well, kind of. We have this odd bug. Okay, let's see. Return true. Return false. Oh snap. Whoa. We're still having trouble with this, it seems. We still collide for some reason. So let's see. Oh wait, no, this needs to be also be this also needs to be true. This is extremely odd. You see, even now, it's super confusing. So if it's within this one, it's gotta only be in this one. Kind of. Oh gosh. Let's comment some of this out. And just say, and there. Okay, that's looking good. It's very odd, but we're fine. That makes sense why it's taking the first one. What doesn't make sense to me is why it's. Okay, let's see. So yes, it's just kind of deleting them as they go. Which makes sense. I don't understand why it's allowing the ball to go all the way up. So we will see in just a second what happens. Okay, yes, it's not getting the bottom bound. Oh. What even happened there? Okay. There we go. Okay, that works. Here, okay. It was simple, it was just misconception with my bracket. Let's try and make this all. Oh, no. Yeah, okay. We still have this error. Let's go back to having this commented out. And you know what we're gonna do? Instead of having this, we're just gonna say ball v equals create vector 0, 10. Okay, so now it's looking good. That was odd how it did that. I don't understand why those two are staying. Hang on. 3, 4, and then it just goes to the next one. Dude, this is so odd now. Why? This is very odd. And then it's just gonna kind of fly up. Oh, no, we still have... Oh, we have the top layer, my bad. Huh. So let's try this. It's so odd how that's happening. I'm perplexed about that. Here, this is what I'm gonna do real quick. Here, I'm gonna continue this and check. So it can be left bound or right bound, and it cannot be top bound or bottom bound. So let's try that. We'll say ball v.x times equals -1, return true. There we go. And we will say 0 or 10 comma 0. What happened? Syntax error. Where is this now? 116? Here. Oh, my bad. Okay, well that happened. Oh gosh. It can't be on the top bound or the bottom bound. It could be either the right bound. Dude, this is so confusing. You know what? I'm not doing any of this fancy stuff. What we're gonna check is if it's in the right bound and top bound. Okay, if it's that, here, we'll check all the top bounds and right bound. Else, that means it has to be within top and right. So it has to be here. Okay. So now what we have to do, you know what? Okay. We're saying the top bound, but we're not specifying exactly where it ends. So we have the top bound and bottom bound, but if it's on the top bound, then hang on, what the heck? Then it has to be within both bounds. Oh, this is difficult. This is very difficult. We have top bound, bottom bound. Those are working completely fine. If it's top bound and right bound, You know what? I think it should be. I think really what it should be, instead of the top bounds being like this, I think the top bounds should be more like this, so that the bottom bound, or the top bound is like this, and the bottom bound is like this. Like it wraps through here. This is the area of it, and it stops once the top bound starts. And I think that's how these should be, meaning, where is it? So if we had like this, and then the purple would come like this, and then same with the top, same with, oh wait, no. The purple wouldn't go there. The purple would actually be going, oh my goodness, what am I doing? The purple would stretch from there to here. Yes, okay. And the red would stretch from there to here, right? Wait, what am I doing? Yes, okay, we're good. I confused the heck out of myself just then. Okay, I think we're good. Although, you know what? Okay, here. Instead of having lower bound and upper bound, I'm going to check var upper y bound and the okay upper y here plane. I'm gonna name it that. You know what? We'll name it bound. Upper y bound is going to equal block.y minus radius. Var lower y bound is is going to be equal to this. So really what I need to do is say, oh, didn't do that. Var upper y plane equals upper y bound. Var lower y plane equals lower y bound. Right? Okay, or we could just kind of use upper y bound, lower y bound. There's really no... Okay. Oh, wait, no. Here is what we need to do. Var upper y bound. No, let's just do y bound equals, and it's going to ask if byv is greater than upper y bound. This needs to be capitalized, and symbol also needs to be less than or lower y bound. There we go. Okay. y bound. We're just having a generic y bound. And then for the x bound, that is going to equal two things also. So b, I don't know why the x is, I mean that j is still there. bxv is greater than left x bound. And it's also bxv is less than right x bound. So here's what we're doing. We're saying just all this area. And yeah, okay. So that's what we're doing. We're saying all of this area, if it's within that. So if we're within the x bound, which means we're somewhere, we could be anywhere right here, anywhere within this space. So let's see. If x bound and y bound, that means we are somewhere in here. Yes, okay. So if x bound and y bound, then we have, that is where we have collision. Let's try it. Oh goodness, not what I meant to do. Well, I mean, it's working. Oh, didn't mean that. Seems to be working. Let's check the other plane. Let's do this one. Yes, it is working. Okay, now let's give it the random. Oh snap. Okay, obviously it's gonna be weird, but that means it's fine. Okay, so we are good. We are golden. Now what we can do is we can say if it's, so that means it's within the bounds. If it's within the bounds, then we're good. That means we can automatically return true. Collision. Okay. So we can detect the collision. Now we have to make sure it's within certain bounds now. So here's where we have if these, that's where I'm pretty sure we can say whether it's true or false. So that means it's within the right bound. Oh, wait, okay. It means it can't be, because now we're back to the right bound, left bound stuff. So if it's only in the bottom bound, okay, here. If it's in all three of them, then we say ball v dot x times equals -1. Ball v dot y times equals -1. Or actually, you know what? We'll say ball v dot x times equals, and here's where we'll have a ternary operator, left bound or right bound. Right? No. Yes. So then we do, if it's in one of them, then we multiply it by -1. If not, then we multiply it by 1. And then the y, let me delete this. the Y is the same way. Top bound, bottom bound. Yes. Yes. Hooray! It's working. There we go. Okay, kind of glitches there. I think we're fine. Okay. Wait. Yeah, we're good. We're good. Nice. I don't honestly know why it glitches like that. Cause, oh, I know why. It's because it gets stuck in the paddle itself. An easy way we could get around that is to make the paddle smaller. So yeah, that's about all. I messed it up. Every time there's a collision, we kind of want the ball's velocity dot multiply. Let's multiply it by 1.05. Here we go. So, yes, okay, cool. I kind of want it slower than that, though. Oh gosh, that goes very fast. 0, 7, 5, no, 2, 5, 2, 5, there, let's try that. Okay. Nice. Looking good. Oh, that kind of was weird. Oh, okay. Oh, combo. Oh, snap. Oh, okay. Yeah, that's good. Maybe we'll add a 175 there. There we go. I think that's good. If it falls out now. If it falls out of the thing itself. Which means we could just kind of be like handleball if ball velocity or ball dot y is greater than height, then we say no loop. And we're gonna take away the mouse press. Let's see. Can we take away the mouse press? Yes, okay. Let's take away in-game, just kind of cleaning things up. And let's say, text, here, okay. Here's what we'll do. We'll say, text size 20. What I'm gonna do is say, every time we draw, we're gonna say, draw stuff, paddle, fill, and we're gonna say, 255, and then we're gonna say, text score, and then we're gonna have var, kind of want this here, var score, and score is actually going to be set to 0. Score equals 0. each time it collides with one of these, we're gonna say score plus plus. And we're gonna check we're gonna check here. End game. We're gonna say false. So we're gonna create a function real quick. Function here. And we'll do it here. Function end game win or one. So if they won, we say text, else we also say text. So we're gonna do text size. The text size is gonna be 50 points, and we're gonna say you win. And then yeah, okay. You lost. You lose. You lose, okay. And then this will be at width divided by 2. Height divided by 2. Width divided by 2. Height divided by 2. And we're gonna say text size 30. Text size 30. Oh wait, no, you know what? And we'll say text, press F5 to start. Width divided by 2. Height divided by 2 minus something like 40. And then we say no loop. There we go. So now I think we're good. We just have to check. Now we just have to check if score is equal to blocks.length, then they won. End game true. There we go. I'm probably never going to end the game. But okay, right. I forgot. Let's do end game. Where is end game? This takes forever. Oh goodness, okay. Let's do fill 255. Cool. Up here we need to say text align center. And down here we need to draw the score. Text. Let's do we'll do score. Did I do this correctly? Yes, okay. It will start at let's start it at like 50. And then height minus 50. There we go. 1, 2, 3. Press F5 to restarts, and we are good. I think that's all. I'll check to see if you can win, actually. Let's make less blocks. Rows or columns, just have one. There we go. Ah, snap, this is gonna take forever. Great. Okay. Here we go. Here we go. Oh gosh, this is gonna take absolutely ages. There. Okay, now I just gotta hit something with 100 width. No, we're gonna actually make it 300 width. Here we go. Yay! We won. And it's over. And that's all. Thank you all for watching. I have stuff set up so that you can do some cool things with the colors. Right now they're just kind of yellow, but you can make it multicolor, you can make it a random color, you can make it a color dependent on their row and column number. Any sort of way, really. But yeah, that's about all. You know what I am gonna do? Color, and we're gonna do call times width mod 255. Here, let's do this real quick. So this is red. 0. Wait. Okay. That's that. And then row times height mod 255. What do we have now? Did I mess up somewhere? Oh yeah. I did. There we go. Okay. Obviously it's not gonna have it, but let's see. How could we make it? Never mind. Okay. So let's set this back. 40 plus 40, 45. It's got to be divisible by 60. 600 divided by 45. 13. Can we do something a little bit different? 35. 30. 30 would be 20. So if I did 25 in width, and I did 30 columns, right? Or no, 20 columns with 10 rows. Oh, looking good. Looking snazzy. We could do other things, like just kind of randomize the colors. And maybe that's what I'll do. Whoa, that was odd. Let's just randomize the colors. Actually, there. Random 255. Oh. Random 255, random 255. Oh, we have a struggle. Right there, okay. And let's make this like 0. Ah, nice. Okay. Cool. This will be the thumbnail. I'm liking it. Anyway, guys, thank you all for watching, and if you have enjoyed, please be sure to stay tuned for tomorrow's. And yeah, I will see you guys later. Peace.